Mr. Vlatko Vlahek.
Hi, everybody, and thank you all for coming here. So my name is Vlatko Vlahek. I'm a co-founder and a CTO of Prototyp. We are a small development and design agency from Osijek. We usually specialize on user experience, user interfaces, and implement solutions ranging from designs for huge web shops to router interfaces and stuff like that. So although our main technology stack is React, and .NET, and Node.js. So my today's topic is containers, the infrastructure for the future. Before we get into the topic on what is the potential future of our infrastructure, let's take a look on what was the past. So this is Kanta. We all had our Kantas, either private ones or the ones in the basements that ran the apps for our clients. And for a long time, having a server in your office was the only solution. It was affordable. Cloud providers were not so big, but you had a lot of issues. So you have a Kanta in the basement, a cleaning lady comes in, she pulls out the electricity because she needs to vacuum clean the office, everything goes down. Their internet speeds were bad, and so on and so on. So that was maybe for the 90s, but beginning with the new millennia, we needed to find a better solution. So the better solution, the current, which is probably still the current baseline, became the virtual environments, which are in the cloud or in some private data center. So what is virtualization, and what exactly did we get with it? Long before, you had one server, one operating system on it. That server, if you wanted to have a very strong server, you needed to go to the store, pick up more resources. It was expensive and hard to scale, and you couldn't do a lot of different things with it. Virtualization allowed us to have one server, one box that could run multiple environments completely different from each other, Linux, Windows, or something else in parallel. And it was a far more cost-effective solution because you could do a lot more with the same hardware for the same amount of money. And let's see some of the basics that we had with virtual machines. So it was usually a virtual instance in the cloud or a private data center. We could put things like Windows servers. Windows 10 Core is maybe the baseline at the moment, or Linux, CentOS, Ubuntu Server, Red Hat Enterprise. It gave us a big opportunity to have multiple isolated systems on the same host. However, the app deployment process on each of these VMs was monolithic. We usually deployed the whole application, the whole services together, and we could have problems with that. For example, if on one virtual machine you have everything, you have let's say it's a hosting server, and you have 10 websites on it, and some of these websites need a MySQL database, some are static, some need Postgres. Issues with one of these systems could really bring all of your application or the whole server down. And unfortunately, if you had more complex applications, we fell into the problem that we needed to spin a lot of VMs. So we want 2 application servers. That usually means we need to spin 2 virtual machines. We need a load balancer. We need to spin another virtual machine, and so on and so on. So while the costs were far more effective and far more efficient than comparing it to traditional servers in the basement, for today's modern applications that have a lot of moving parts, this is maybe not sufficient anymore. So what are really the common problems in having a virtual machine with the hypervisor today? First of all, it's the works on my machine problem. Unfortunately, I've heard this a lot more times than I would have wanted. So you have a developer, he develops a code, he tests it on his new Mac or on his new Windows 10 machine, and we deploy it to production and it doesn't work, or things break. What's the problem with that? One of the issues is definitely when you have a VM in the cloud, somebody needs to take care of it, but you see you have an outdated driver, and somebody just clicks next, updates the driver. You need the dependency, somebody sits and he installs the new dependency. But the problem is that all of these changes are hard to track and they're not really propagated to your development environments or to your test environment. The huge problem is if you have multiple environments for a huge app, dev, staging, test, and in time they all start to diverge. And it's really, really becoming hard to keep all of these changes tracked and to sync them. As I told now, it's rather hard to maintain dependencies, versions, and updates of things today. And each virtual machine has a full operating system, which has some pros, but it has a lot of cons today, that every virtual machine became very resource greedy. Now, my company, we work with two types of clients. We either work with small startups, where we do everything from project planning to design, even corporate identity design to implementation of their services, both on back-end and front-end, and large enterprise clients. What's the same for these both types of clients, which are very different, is that both need to save money. Small startups don't have money to throw, so they want you to find the most resource-effective solution for them. And big enterprise clients, they already throw a tremendous amount of money into their infrastructure and services. For example, we have a client from Canada. They're a multinational company, but they're a company that has 24,000 employees. So I am managing, I'm a consultant on their multiple environments. So their cost was, I don't know, $30,000 per month for infrastructure. So if you manage to optimize 10% for a client that's paying $30,000 per month for his infrastructure, that's great work. And resource greediness is probably one of the biggest bottlenecks of current VM implementations. So there is another issue. Considering that each virtual machine and each moving part of your application has a full OS, you need to update them from time to time. And if on the same host you have a lot of virtual machines, if you need to update all of them, it takes a lot of time. It can cause a lot of downtime for you. So, and change history, installations, uninstallations are hard to track. So for one of my clients, I tried to handle this situation a few years ago. We worked with a software that's called Puppet Enterprise. I'm not sure if everybody used that. Hands, maybe? Okay. So what's the problem? In a huge infrastructure where you can't track changes easily, we told our clients, okay, let's find a way how we can version your changes to the environment. And Puppet Enterprise was a good solution, although highly complex, where you have one provisioning server that has the configuration files for your whole infrastructure, and all of the machines in the cloud, they have agents connected to this provisioning server. You cannot change anything. For example, you install a new program, Puppet will uninstall it. It forces you to push the change installation of a package or something to a YAML config file. So we handled that, let's say, in a manner that we started code versioning our changes to the servers. But it was highly complex, and in real production sense, it was never effective. However, today, with the rise of microservices and the focus of optimizing software, infrastructure, and everything has changed. Today, when we are talking about optimizations, we can't really just talk about optimizing your infrastructure or your app. It's the whole ecosystem that needs to be brought together. So I know a lot of companies currently speaking about microservices, and it's an interesting topic. It's, for example, you rarely have an application that has an app-wide bottleneck. Usually, the bottleneck is maybe the amount of connections that your web servers get, or the bottleneck is the database. And when you have a monolithic app approach with a single VM where everything is installed, it's kind of hard to scale that up. The other thing is if you have multiple VMs, which is expensive, where one is the database, some are app servers, and so on, you can spin up a new VM, but you also have the problem if somebody is going to click next, 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 you can introduce some differences between your environments. And if you will go to code-like approach, Bash, PowerShell, you need to find really great sysadmins who know each of these languages in depth. So with Docker, we switched from the virtualization standpoint, the normal one, to a containerization. Unlike the virtualization system that has a hypervisor that handles each VM with its own full-blown operating system, containers work in a different fashion. So here is Docker is an example, but I have a list of different providers. You have a host operating system that runs Docker server, which is relatively, let's say, it fits a similar purpose to hypervisors from VMware or Microsoft Hyper-V. But the huge difference is that Docker is connected to the host operating system. Not every container has its own OS. It uses everything it can from the host operating system. And you can have a lot more applications than a lot more containers than you would have normal VMs. So available solutions at this time are Docker, Vagrant, Mesos. There are some older, maybe smaller solutions. So Docker was definitely not the first one. It's maybe the most widely used one today. But let's see a few pros of using containers today. So it's easy reproduction. Considering that for each container or application instance, you would build a Docker or image for any other provider, we have a situation where one person builds the image, it can distribute it to its teammates. When they run it, they will get a full app with the OS, with all dependencies set up, versioning, and so on. And that image can be used both in development, on test, on staging, on production. So it handles and it synchronizes the issue with mismatch of dependencies and stuff like that. So versioning. Containers cover versioning great, considering that when you build a new image for your application or a microservice or something else, it gets versioned. You push it to an image repository. There are multiple solutions, but Docker, I would say Docker Hub and AWS has their Elastic Container Repository. Azure has Azure has their own solution. So big players are allowing us now to store versions of our microservices at their repositories easily and cheaply. So we resolved the big issue of versioning our infrastructure in a manner. App isolation. Each container, this works very similarly to how virtual machines are isolated. So each container it has a set of its own dependencies, but it doesn't. It cannot break anything else. Let's say you have an application that consists of a mailing server, a database server, and a web server. So you would deploy 3 containers on the machine. One would only have Nginx Nginx web server, for example, and the web app. The other will have the database, and the third one will have the mailing server. You want to exchange the mailing server, you will just disable the container that has the mailing server and push an image with another one. So it's much easier to kind of find drop-in replacements to parts of your code. The other thing about, which is more tied to microservices than containers, is definitely that they allow us to write sections of our code in completely different technologies. One of the biggest things about containers is that they have very small footprint. So I have deployed container services that take as less as 40, 50 megabytes of RAM, which is impressive. So you can run your whole application in a few containers in less than half a gigabytes of RAM. And of course, usually a single host can run a lot more containers than it can virtual machines, because you don't have a copy of the whole operating system in each one. Security, considering that we are talking about app isolation here, usually if something breaks in your container, it won't affect the rest of the application. Although, as they are directly connected to the host operating system, if the host operating system has a security flaw, it will compromise all of your containers. And as far as continuous integration goes, you can easily deploy new versions of specific microservices as containers. And one of the biggest changes in comparison to the traditional approach is you have deployed a new version of the mailing server. You can see that it doesn't work okay. You will just use your CI tool to deploy the version that worked before, and it will spawn in an instance. For example, as far as deployment goes, one of the great things about containers is that you have much less downtime than you have with normal VMs, because most of the orchestrator providers online, if you are deploying a new image, they will spawn the new instance with the new version, then kill the old instance and just transfer the routing. But for example, Azure, AWS, they do it automatically. Your users don't feel that. If you are if you are versioning your API, you can deploy a fully new version without, I don't know, maybe 100 millisecond, 200 millisecond downtime. It's impressive. And a great thing is that there are a lot of pre-made images for big software, such as Nginx, databases, and so on. So most of your application, you can download images that are pre-made and connect them together. And it's much easier to track performance of a specific container, which Docker does for you, than, for example, having a host with 10 websites and going through the logs and see which website is really breaking your app, taking much more resources than needed, and so on. And there is no host OS emulation, so containers usually work faster than virtual machines, but not as fast as having something installed in a bare metal environment. So do we have any issues? Yes. You cannot, if you have a host that needs to have services in different operating systems, you still need to go for the traditional virtualization. Hypervisor provides a bit more sandboxing security-wise than containers do. Container technologies are still relatively young, so they're not as stable and not as well documented as traditional VMs. Okay, and that's kind of it. Do you have any questions? So I have to say, a little disclaimer, we started implementing microservices in our own test projects. We still don't have any real production-wise product with it. So I am interested if anybody from the audience has used Approach with Docker or any other solution and implemented it for their clients, and what was the feedback? Okay.
So we were discussing containers 5 minutes before your talk. What do you think What's your suggestion if I have one monolith application, web application that is running within IIS?
Okay.
Is there any benefit from converting this application to the containers? So I have one virtual machine. Will I have any benefit if I move my application to containers?
Probably on a small systems.
Sorry,
Okay.
I know that that's not the purpose of containers, but I just want, because I believe that majority of cases here that we have like applications in that kind of environment.
Okay, so there are services such as Azure or AWS allow you to launch apps as containers through their services such as Elastic Beanstalk on AWS. I'm not sure what's dependent on the Azure. So you can probably launch a container app there and pay, and at least get it to automatically scale to what the amount of resources it is utilizing. Because in normal IIS scenario, you will still launch a VM, you will choose the amount of RAM, amount of CPU, you will underutilize it or overutilize it. So deploying a container in one of the services made for that on Azure or AWS or any other provider will at least give you better metrics, and it will maybe scale better with the performance that you need. I would say that the first step, if you want to optimize your infrastructure, is to maybe try to go serverless for less complex applications, and try to do a combination maybe of static and some serverless technologies such as AWS Lambda or Firebase functions or Azure functions that were showcased here. Go to containers if you have a little bit more highly complex scenario. And for big apps, very complex monolithic that you had from before, it's usually best to stay in the traditional approach until you are ready to really code-wise restructure them to really support the container purpose to their full extent. Any other questions? Then thank you all for coming. Have a nice day.
Thank you, Vlatko.